MS Ramaiah University of Applied Sciences.
Hi students, let us discuss determination of liquid limit. The aim of the experiment is to determine the liquid limit of the given soil sample as per IS 2720 Part 5, 1985. Consistency of soil is its resistance against deformation. It represents the relative easiness with which the soil can be deformed. Consistency limits relates to the degree of firmness and is directly related to strength. These limits are applicable to clayey soils and is a function of water content. As water content decreases, the soil changes from one state to another. Liquid to plastic, plastic to semi-solid, and semi-solid to solid. Liquid limit is defined as the water content at which the soil changes from liquid state to plastic state. Experimental setup: Casa Grande apparatus, grooving tool, porcelain evaporating dish, flat glass plate, balance, oven, wash bottle with distilled water and containers. Adjust the cup of the liquid limit apparatus with the help of grooving tool gauge and the adjustment plate to give a drop of exactly 1 cm on the point of contact on base. 120 grams of air-dried sample passing through 425 micron sieve should be taken. Mix with distilled water and knead until the sample achieves uniformity. Place a portion of this soil paste in liquid limit cup and level it. Trim it to a depth of 1 cm at the point of maximum thickness. Using the grooving tool, cut a clean and sharp groove in the middle. Lift and drop the cup by rotating the crank at about 2 revolutions per second. Count the number of blows required to make the halves of the soil pad separated by the groove meet for a length of about 12 mm. Take a representative portion of soil from the cup for water content determination. Repeat the test with different moisture contents for blows between 10 and 40. Plot the number of blows and corresponding moisture content. This graph is known as flow curve or flow graph. Obtain the moisture content corresponding to 25 blows from the flow curve, which is the liquid limit. Data collection and tabulation is as shown in the table. Flow curve obtained is as shown in the figure. Calculations and computations. Draw a graph showing the relationship between water content on y-axis and number of blows on x-axis on semi-log graph. The moisture content corresponding to 25 drops, that is blows, is called the liquid limit. Flow index IF is given by W2 minus W1 by log N1 by N2. The results of liquid limit WL and flow index IF are presented.
Dear students, today we will conduct the consistency limits experiment. First, we will start with the liquid limit determination. The aim of this experiment is to determine the liquid limit of the given soil sample. The apparatus required for this test include a weighing balance. The weighing balance is used to measure the soil sample for the test. The Casa Grande apparatus consists of a brass cup, a handle and a dial for counting the number of blows. It also consists of a grooving tool and an adjustment plate for adjusting the height of this brass cup. You can adjust it like this. Moisture can is used to determine the moisture content of the soil sample. The porcelain dish is used to measure the soil sample for the test. Measuring jar to measure the amount of water for mixing in the soil sample. Spatula. The spatula is used to level the soil sample in the brass cup. Tray. Trowel. The metallic tray as well as the trowel is used to take the soil sample. and sieve. A sieve size of 425 micron is used for sieving the sample. It consists of a pan for collecting the sieved sample and a lid for covering the sieve. Now let us start the experiment. First, we will take the soil sample and sieve it through 425 micron sieve. Open the lid of the sieve and pour the soil sample into the sieve. Now close the lid and we will sieve it manually. After sieving the sample, open the lid, remove the sieve and collect the sample in the pan. Now to measure the soil sample, place the porcelain dish on the weighing balance and tare its weight to 0. Now pour around 120 grams of the soil sample into the porcelain dish. Now mix around 20% of water of the dry weight. We have taken 120 grams of the sample, so 20% of that will come around 24 ml of water. So we will add 24 ml of water to the soil sample and mix it thoroughly. After mixing the soil thoroughly with the water, fill that sample in the brass cup of the Casagrande apparatus. Now fill the brass cup in such a way that there is a minimum of 1 centimeter depth at the middle of the cup. Level it using the spatula. After smoothing the surface using the spatula, create a groove through the middle of the brass cup using the grooving tool. The tool should be perpendicular to the soil sample. After making the groove, we have to rotate the handle at 2 revolutions per second. Now the rotation should be continued until this hole will close by about 1.2 centimeter in the middle or anywhere. At the same time, we can read the number of counts in the dial. Now you can see that the groove has closed and the number of blows is around 52, which indicates that the water content in this soil sample is very less. Generally, the water content which you are adding should be in such a way that the maximum number of blows should come only around 35. So the trial should be repeated with a large amount of water, and you have to repeat this in the same way for 4 to 5 water contents. And each time the test is done, you have to take a small amount of sample in the moisture can and keep it in the oven for moisture content determination. Now take the soil sample from any part of the soil sample and put it in the moisture can. This sample should be kept in the oven for 24 hours for completely drying it, and later the weight should be taken. The weight should also be noted, as well as after 24 hours the dry weight should also be noted. That gives the moisture content for this particular number of blows. Repeat this for different amount of water contents until you get the number of blows around 15. Each time you measure the water content and note the number of blows and plot it. That finishes the liquid limit experiment.
At MSR UAS, we spark your imagination unlike any other.